Hey, everybody. Thank you for joining. We're going to give this just a minute here and let a few people filter in. I see some numbers edging up, and we will get started digging into the Information Risk Insight study for ransomware. Okay. I think maybe let's go ahead and get going with some intros, and by the time we roll into the stats here in just a minute or two, then that'll give a couple more minutes. But I'll go first, hopefully not being rude, but Wade Baker, one of the co-founders of Cyentia Institute, and was involved in some of the aspects of doing this study. I also will give some time for other Cyentia people to say hello, but first I want to introduce our extra special guest, Dr. Olga Livingston from CISA. Olga, you want to tell us a little bit about yourself and what you do there?
Sure. Olga Livingston. I'm principal cyber economist at CISA. I've been supporting cybersecurity division for, sounds scary, almost a decade, and trend analysis, ransomware and all incident types, loss magnitude, likelihood. That's part of the work that I'm doing at CISA and truly enjoy doing. So thank you for partnership.
Thank you for doing that work. I feel like there's too few cybersecurity economists out there. So thanks for being one of them. Other Scientia people, you want to say hello? Just so you know the crew.
Hello, everyone. I'm the man behind the slides this evening. This is David Sabersky here. I was support for this report there, but Wade and John Sturgis, who I believe is also on the line as well, were the primary analysts on this one. So I'm happy to be here and support everyone for questions.
And as David mentioned, John Sturgis here, data scientist at Cyentia Institute, ran the analysis behind the report for IRIS Ransomware, and also answering questions and anything like that in the background.
Doran, you want to say hello, or you can be
Sure. So this is Joran. My name's Joran. I'm also a data scientist here at Cyentia. I was not as directly involved in this report, but I participate in other reports and support other work that we do here.
not least, Carolyn. You'll probably be hearing from Carolyn soon, so want to make sure that name's not unrecognized.
Welcome to today's webinar. I am Carolyn. I am the digital marketing coordinator here at Cyentia Institute, and I also lay out the reports. So I am the one responsible for the public-facing look of this report.
All right, and few people have mentioned Cyentia rep standing by to take your questions. There's a chat window. Anytime you have a question on a slide we're discussing, feel free to drop it in there. We'll try to get to those as we go. If one of the questions, David, John, Joran, you think needs to be addressed as we go verbally, fire away. And then at the end, we should have some time for Q&A as well. So with that, I think let's jump in, David, and I want to first give our acknowledgement and thanks to CISA for sponsoring this. I mean, we're a research institution. We love what we do, but we all have families and got to eat and things like that. So really appreciate sponsorship of this kind of work. It lets us do what we love doing and share this with you. So Olga, to you and others, thank you. And I've heard a lot from readers of the IRIS series that they appreciate it as well. So definitely thanks for that. You have anything of why this kind of thing is interesting to CISA? That may be curious for people that are wondering, what's this about?
Yeah, my standard spiel is, it's hard to inform risk management decisions when you do not have data to inform it. And we have very sparse, scarce data on actual occurrences of incidents. There's not a standard incident statistics. So for some more, and it's not a matter of stats as far as methodology. It's a matter of what is reported out there, what is reported self-disclosed. So we're at the mercy of the industry and the publications. There are not that many comprehensive data sets out there. Therefore, it was our best intention to first go through all available literature in the industry that deals with estimates, and that was a systematic review and cross-validation. And once we identified trustworthy sources with solid methodology, we pursued those. And we're extremely thankful for you being one of the research institutions that kindly agreed to partner with us on this.
We like the partnership for sure. All right, so let's go to the next one. I think most of the people on this are probably familiar with the Information Risk Insight Study, or IRIS series, but just in case you're not, this has been going on for getting on near 5 years now. We started in 2020 with the first IRIS, and we've kind of flopped back and forth. The IRIS 2020 and the IRIS 2022, which was also, by the way, sponsored by CISA, are sort of your high-level overlook at widespread frequency and loss trends. And then we've kind of done these very specific takes. The IRIS Extreme, we took 100 of the largest incidents at that particular time and did a deep dive. And then the IRIS Tsunami looks at multi-party incidents that not just affect one organization, but where the incident or impacts of it overflow and impact many organizations. So if you're interested in this kind of work that we're talking about today, all of these are available. All of them are free. None of them require registration. So you can just go grab them and read them and share them as you like.
This is where the value is, as we have a consistent series where the methods understood and the data frame that we're using is comparable from year to year. We're looking at different aspects of this data, but this gives a citable reference where we truly understand how the estimates came to be and what the underlying collection method is. So the continuity has a certain value to it as well. Thank you.
Agreed. All right, let's go. So a little bit about what you're looking at here. We are starting with a data set from Zywave or Advisen. They collect a ton of publicly available information, and they do this in all sorts of ways. Mandatory disclosures, cases that come up as these things are litigated, the voluntary disclosure or reporting via the SEC, FOIA requests, all kinds of ways that incidents get flushed out into the public knowledge. And Zywave and Advisen is trying to grab up those and collect some data on them. So we start there. And we do a lot of additional enrichment here at Cyentia Institute. So for example, the fact that we know that it's a ransomware incident is something that we do. There's some of that coming in from Advisen, but we try to enrich that. We're going to talk a little bit today about attack techniques and other things like that. All of that, those are examples of enrichments that we try to add on top of this data. And then we also are featuring some supplemental data from Tidal Cyber, Ransom Watch, and Fortinet, just to give a little bit of flavor around that core Advisen, Zywave, and then the Cyentia enrichments. The data set is really between 2014. What we're looking at from that data set is ransomware events that occurred between 2014 and 2013. We spend more time on the last 5 years of that range, but you'll see several charts that span the whole period. And there's some verbiage down there. One thing people ask about a lot is a ransomware event, a ransomware incident, a ransomware loss event, sort of all the same kind of thing. We're talking about incidents that occurred for ransomware.
Yeah, and what motivated this specific study is previous edition looked across multiple incident types, and we're working on a forthcoming report that also does an update to that. And in the meantime, there was such a significant uptick in the ransomware that it warranted a special look.
Yeah, it's actually our first dive into a specific type of threat. So it was a lot of fun for us in that regard. All right, let's start with some big picture stuff. If you think about, how does ransomware rank relative to everything else, I would suspect that a lot of companies sort of put ransomware in their top 3, at least on their radar of risk scenarios that they're concerned about. And it's kind of interesting. So let's do the next table here. So this, we mentioned these incident, we call them incident patterns, but these are part of the enrichment that we do. We try to classify all incidents into one of these patterns that you see here, ransomware being one of them. And if we look at the first 5 years of that 10-year spectrum, ransomware was ranked number 6 in terms of the frequency. It accounted for 1.8, less than 2% of all incidents in the data set. And in losses, less than 4% of all known losses at a 5th place ranking. Then fast forward to more recently, 2014. Can you hit? Sorry, next page, David. That jumped up to number 2 at ransomware being almost a third of all the events in the data set and over a third of all financial losses that we know about in the data. And that puts it at number 1. So again, when you're thinking, we all have this sense that ransomware has increased, that it's more of an issue now than in the past. But I think these numbers put some context and specifics around that. Olga?
Yeah, and this specific finding has value because it's not just an artifact of the specific data set we're working with, that where we're at the mercy of self-disclosure, but validated it with a digital forensics incident response companies. I'm part of the ransomware advisory group, where we meet quarterly, and another private public sector partnership in intelligence, where we meet quarterly and discuss what it is that DFIRs are seeing on an ongoing basis. So these are the findings that validated with what DFIRs are seeing. And also in the artifact of this specific analysis, system intrusion is kind of this big bucket, right, of events where various types fall or belong to it. As a result, by being broadly inclusive, it outweighs ransomware as a category. But if you talk to the global leaders in digital forensics incident response, it was really during COVID, there was an uptick, then it slowed down a little bit, and then increased again. Now it's a leading trend with business email compromise catching up, if not outpacing. But it's been a significant trend as validated by DFIRs.
And speaking of trends, let's look at this. So we have a section here on the frequency of ransomware events, starting with the trend. And this is a bit of a relative trend here, looking at ransomware as a proportion of all incidents in the data set. Starting out at 2015, very, very low, single-digit low percentage points. Whereas when we started 2024 here, by the time we were done collecting this particular set of events, ransomware is about half of all known incidents. And this is a 12 months sliding window here. But overlaid with this, we've kind of put, in doing some research into what's going on here and why this increase, we found this Atlantic Council brief, Behind the Rise of Ransomware, quite useful. And it's linked in the report if you'd like to look, or just Google that, you should be able to find it. But they had these eras, with take it or leave it, or kind of the strategy of the ransomware actors, like, hey, here's, pay us X, and if they don't pay it, okay, we'll move on. A pivot to more targeted attacks and generally larger payloads and demands. And then just the professionalization and criminalization of it in the last few years here has really helped to to drive that increase that we're seeing, where ransomware, is a favored technique among cyber criminals for lots of reasons. And again, Olga, I think you have much wider visibility into a lot of these things at your position, and sounds like you're seeing a lot of the same stuff.
Yeah, and a couple aspects contextualizing that uptick is once the organized ransomware groups broke up, you have uptick in a sporadic disorganized activity. One and another one is not stating the obvious, but nevertheless, that's where the money is. Because if ransoms are paid, that inadvertently, Economics 101 creates a demand signal for ransomware, right? So the reimbursement of the ransomware as part of the claims arguably might be partly feeding that. It's not in any way to put attribution, but nevertheless, if we compare rates of ransomware in the US and rates of payout of the ransomware in the US with the rest of the world, there is a significant difference. And now those two correlate. So there is more than one reason as to why we see that uptick, but inadvertently is because that's what it pays. That's what pays.
Money. All right. So you saw the proportion of incidents as a trend there, trending up. This is the same kind of thing, proportion of all incidents that are classified as ransomware, but on a sector basis. And I think it's pretty interesting as you look in this list that there are industries where about half of their incidents are ransomware. And then you see some other industries where it's still significant portion, but less than that. So financial, public sector, and healthcare down at the bottom. And my take on this is those ones at the bottom tend to be highly regulated and have mandatory disclosure and other things like that. So I think we see a lot of healthcare and public sector disclosed incidents of a wider variety, whereas in maybe manufacturing and other things like that, a little less PII driven incident reporting. And so when these ransomware events happen, they knock things offline and they can't manufacture stuff, and that becomes a public event. And so you tend to get a higher proportion that are sort of hijacked, for lack of a better term, by ransomware. I don't know. Does that make sense there, Olga?
Yeah, no, this is to emphasize the artifact of the collection or approach to collection is if we rely on what's publicly available and then disclosure, materiality threshold, depending on which accounting firm you talk to, but big four, it could be anywhere from 2 to 8% of annual revenue that's considered to be less than material. That creates that variability as to what a large firm versus a small firm would consider disclosable or subject to that disclosure. It's not a requirement, it's a guideline. And also we see a tip of the iceberg, but we're not really sure if we're seeing 5, 10, 15% of that. There's no depth perception of what those unobserved, unreported incidents are. So multiple caveats, but nevertheless, the trend is where we see larger, more expensive ransomware events in the particular sectors.
And then we could do that same kind of thing by not sector, but organization size. This is based on the annual revenues of the victim organization. And this is an interesting trend because you're seeing the top one, 9%. 9% of the known or reported financial losses from all cybersecurity incidents for 100 billion plus revenue companies are associated with ransomware. So, 10% of their losses driven by ransomware. Whereas you look some of those smaller and mid-size, you've got a third or more of their losses that are driven by ransomware. And I think again, some of that is based on big companies have big company problems and generally larger losses. But as a share of revenue, this is making an argument that ransomware is kind of a bigger deal for smaller companies, relatively speaking, in the grand scheme of cybersecurity events.
And if we compare that with the value added in the US economy that's generated by small, medium-sized businesses and the exposure to the ransomware being very significant, those are the two data points together that make us pay closer attention to what it is that SMBs need to manage the risk. as the stakes are different, a cost burden is much more felt by the SMBs.
And I'm sorry, I just realized that I misspoke. I said percent of losses. We're looking at percent of incidents here. We're going to show you a slide in a moment that is percent of losses. So I just wanted to correct that. This is percent of all security incidents that are ransomware for each of these. So we, like I said, we'll get to losses perspective of this in a moment. So when we talk about frequency, we want to leave you with, you know, some estimates. If you really are interested in expected frequency, probability of having a ransomware event, then I would refer you to the report. We go into detail about how we built a model based on these events, and we show some, you know, how well is the model fitting, and all of those kinds of things. I'm not going to include those details here, but just notice that the table here is kind of showing an interesting finding that if we look at those different revenue categories and the probability of having one or more ransomware events in a 12-month period, there's less difference, at least than I expected. Like generally, when we do this, the probability of large organizations having an event is significantly higher than small companies. But I think ransomware seems to be a little bit different there. I mean, sure, 13% rounded up is a little bit higher than 10%, but not by a huge difference. And I think that's because of the sort of opportunistic nature, at least in some parts of ransomware, and the fact that it kind of affects all of us. Where you do see a difference is the chance of having 2 or more ransomware events. So the chance of in any given 12-month period, a large company suffering multiple ransomware incidents is much higher than a smaller company. But if you're interested in that kind of thing and want some numbers to supply those risk models, you'll find them in the report.
And it's all based on relative frequencies, of course, within the data set, but recognize that it's a defensible lower bound because we do not know what's the portion that's not reported there. You know, within the confines of a collection that of this data set still can pick one as a at least value.
And this is David here. I'm kind of jumping with a question from the peanut gallery here. Not sent to everyone there. So there's a question about whether or not this is over a 12-month period and what's the time bounding. I'll just respond that the percentages that we're showing in terms of, you know, the probability of having 1 or more or 2 or more is over a given 12-month period. But the general time period that we've done for most of this analysis is on a 5-year period, that being from 2019 to the end of 2023. Though in some cases, as I think Wade mentioned earlier, we do look at a 10-year trend as well.
Yeah. All right, let's talk about losses. This is where I think there's a couple things that are important to say here. One, when we talk about ransomware losses, we're not just measuring the demand that the criminals gave or what they were paid. We're at least trying to get comprehensive losses that would include incident response costs, that would include perhaps lost revenue and sales from a manufacturing firm that was locked up or a retail institution. We're trying to include any claims related data from lawsuits and whatnot. All of those things are not always reported. All the losses aren't always reported, at least at the public level in total. But that's what we're going for. You know, a lot of these are more than just the ransom demanded. Second important point as we look through this is that we have losses for just a fraction of the 14,000 ransomware, like low hundreds of those actually have loss information included in them. So there's a lot we don't know about. And so what you'll see here is based on what we do know. And from those, you know, hundreds of ransomware events where we have loss information, one of the things that you'll notice is that the typical loss, which here is the geometric mean, is about 10 times higher than the typical loss for non-ransomware incidents. So, you know, it is a true statement to say that in general, ransomware incidents are more expensive, more costly than other types of security incidents. And that holds true when you talk about more highly impactful. So that 95th percentile, we sometimes call them extreme ransomware loss events at almost $50 million, are also more than double what an extreme event for a typical other non-ransomware cyber event is. So I think this kind of fits in with what a lot of people, I think, have felt and premises about ransomware cost.
And this is where I go in the lecture mode because the teacher in me gets excited. There's a reason why we're using typical and geometric mean. Because if you have long tail distribution, a lot of extreme values in the tail, it really impacts average. Average is not a stable statistic for it. For example, in the previous report, IRIS, average also happened to be 95th percentile. So my students, dear vendors, when somebody pops up with a report and says average cost of the incident, that's like immediate acid reflux, right? So especially if you're reporting average across 4 or 5 points and you're not disclosing me what the min max and the rest of the juicy behavior is, that tells me precisely nothing and kind of takes the credibility away from the good research that might follow. So please, when you package these results, any publications, your own analysis, I understand I'm talking to a diverse audience, keep that in mind. There is a reason we harp on it in every presentation we make.
I love that you said it. We always try to hit on that, but you know, Olga, those average numbers are higher, which is better, right? That's going to drive more investment and get everybody scared
ROI.
more. No, I'm totally kidding.
Unobtainium, another metric that requires discount rate. Plop that on top of the average, and oh, that looks good.
Yeah. So how is that moving over time? Those typical, these are, if you're familiar with box plots, these are violin plots. It's just a distribution. But if you look at the typical, again, it's you know, what is quote average, not the mean, but a typical event just in 2019, 686K. And
David, you are showing. Thank you.
Yep. All right. Thought that was me for a second. 686K is a typical event back in 2019. And if you fast forward, it's 3.7 million in 2023. And I find it interesting that a typical event in 2019 is now about the lower quartile, the 25th percentile in 2023. So, you know, you can just kind of imagine things sliding up over time as ransomware events become more and more costly.
And just to contextualize or a quick recap of what we're looking at, box plots. So you see typical, and then 25th percentile, 75th percentile. So you get interquartile range, and then the tail. So it's interesting to look at the specifically 2023 plot, see the relative area or mass associated with the higher cost, higher loss events, right? So that's that bulge up on top. So we are having more events, and we're having more of the more extreme events.
Let's do the next slide. Here we go. So we showed this same chart for frequency a while back, and this is the same kind of thing for losses. So in the transportation sector, 84% of all known losses from cybersecurity incidents are tied to ransomware events, which is pretty shocking. And again, we see public sector information and financial on the lower end. I think that's because, again, the regulation, a lot of those come to light, and we kind of maybe know a more complete picture of those. Whereas some of the ones on top, the loudest incidents are the things that become public knowledge, and those tend to have a high price tag in many cases. And so the losses that we know about are dominated by those biggies, and I kind of think that's what's going on here. But you know, ransomware causing very high proportions of losses in some of these sectors. Now let's look at the same thing for size. Again, I referenced this earlier, and you see kind of the same pattern that you saw on the frequency side. Ransomware specific losses for really big companies are much smaller than they are for the smaller and mid-size. And to a certain extent, that's because these larger companies are having a more diverse set of security incidents that are occurring to them and that also have losses. Whereas some of these smaller ones, ransomware is kind of their biggest issue by far, and they tend to consume both the frequency and loss side of what they're dealing with.
And that's what I essentially earlier jumped ahead. Wade, thanks for pulling back the discussion to frequency. But those are the 3 slides that you want to look side by side. Frequency, the brunt of the losses shared by this subset of companies, and then what the losses mean relative to their revenue. Jointly together, that's where it again highlights how the disproportionate burden of ransomware incidents and ransom. So we're not talking about ransom payments, but overall total cost of ransomware activity is shouldered by specific subsets of the economy and specific sizes of businesses.
Yep, and I think we have a slide on that sort of side by side, looking at frequency and losses together. And if you can put the sort of frequency charts that you saw and the red loss charts, this is what you would get if you merge them. And I think if you look into the upper right area, those on the left chart for industries, education, manufacturing, transportation, are industries where ransomware events are both relatively common within that sector and also responsible for a large proportion of losses, aka a large share of risk for those. And same thing on the company size, whereas you see on the really large organizations, it looks kind of smaller, but keep in mind the total losses might be more. But we're talking about relative here. All right. So want to get into something that we've never actually done this before. So I mentioned before that we have loss information for a smaller subset of all known ransomware incidents. And so, if we just look at those, we get something like, all right, there's, $2.4 billion in losses across them. But it's more than that, obviously. But we wanted to figure out, all right, what can we say perhaps about the estimated or projected total losses for ransomware? So since we can model the loss distribution of the known incidents, we can sample from that and apply that to where we don't have a loss information for ransomware events and see what we get. And that number is much larger, $274 billion projected losses across these ransomware events that we know about over the last decade, which is quite a large number. And you could make the argument, okay, well, maybe not all of those incidents had losses, but again, they're publicly disclosed known incidents, so there's something. It wasn't just quietly swept under the rug and machine reformatted and done. For some reason, it came to public knowledge and is part of the public record. So there's something there. And our loss distribution does cover some really small numbers. There's some there between 1,000 and 10,000 incidents. So we have a pretty wide distribution covering a range of minor to major events. And if we just apply that to all of our events, that's what we get. And Olga, I think this crosses over into the economic question, right? This is big picture stuff.
And I've shamelessly done this before with much more sparse data. So thank you for defensible, referenceable citation that I can have now. It is a recognized technique of how you fill the blanks. It's the credibility of it is based on how much data you have to sample from to fill those blanks. So this is quite helpful and advancement from what we had before. It also allows us to talk about broader sectoral views of the risk, because the same technique could be applied at the sectoral level. And ideally, to enrich this information, you want to have combinations of the characteristics, various combinations of characteristics that would help you inform refined, more intricate sampling. But that's an artifact that's a bane of our existence there's not one ring to rule them all. Advise on Zywave is the workhorse data set of the cyber insurance industry, for example. Different entities accumulated their own data sets, but there's not a one meshable pool of data where we can consistently conduct this analysis. So this is a step in the right direction. We're hoping that we can enrich it further as the data becomes available.
All right, and we can trend those projections over time, and that's what you're looking at here, the red segment being the portion of losses that we know about, and the sort of dotted lines being those projections based on the approach that we just mentioned. This chart, notice the y-axis is on a log scale, so the difference between the red and the top end of the dash line is quite large numerically, but even though it doesn't looks so much visually. But if you just look at what's going on here, again, rewind 10 years, we've got much smaller numbers, even on the projected side, than we do over the last few years, where we're up, into 100 billion territory and that kind of thing. In line with what we've seen previously, that there's an increase in the total projected cost of ransomware as we go forward in time.
Yeah, so and that projected, this is not a speculation of the frequency changes. It's based on fill in the blanks of the data points that don't have cost enter associated with it. And there was a question how you define the losses and costs. Advicen has a fairly well-defined structure as to how they collect this data and compile this data. And if you want more details, CISA has a report, appendix in the report. Has a more detailed nomenclature. The fact that we can categorize something as a cost doesn't mean that we can get a number for it. But this is the why do I care slide, right? This is the significance of activity, and combine that with what we mentioned earlier is that this is still tip of the iceberg, right? This is the reported events for which we have estimates or fill the blanks based on the existing estimates. We do not know if this is 5% of what's occurring, 10% of what's occurring, or 75% for what's occurring. That is the portion that it's not forecast, it's not projection, it's truly the unknown, unobserved piece.
All right, and yeah, let's move into TTPs. This is kind of neat. I mean, we were just talking really big picture economy level stuff for ransomware losses, and this is like dive way down into the weeds of which tactics, techniques, and procedures or attack techniques are associated with ransomware. And in the report, we use some data provided by the companies mentioned before that goes into the ransomware groups and the strains of ransomware that are common. But I'll just highlight a couple of charts here as we move forward. Initial access is a big question when it comes to, all right, well, how do we start defending against these ransomware attacks, right? And this is an attempt to answer, well, what is the initial access method or techniques used by various ransomware campaigns out there? And again, you have kind of a frequency breakdown. 21% of all ransomware events used exploit public-facing application, that MITRE attack technique T1190, as an initial access technique. And then on the loss side, the typical loss is about $35.3 million for incidents in which that technique was used. We can't necessarily attribute $35 million of loss exactly to that technique, but what we can say is that when you look at the cost of incidents in which these various techniques are used, we can kind of get a sense of which techniques are associated with larger loss incidents and maybe more minor lower loss incidents. And I think that informs risk decisions and assessments, hopefully.
And this is a specific example of enrichment that's very, very helpful, because Advicen does have a cross-section of the cost, losses, and occurrences, but not necessarily this layer, deeper layer as to what happened. Ideally, we would want to have it organized by MITRE attack, right? So you can trace through. Well, that requires a body of knowledge where all these attack, blood spatters, attack anatomy combined. Well, incidents in the federal sector, incident reports are quite often classified, and incident reports in the private sector reveal more than just security posture. So there are lots of bits and pieces that could immensely enhance the analysis, but we're limited to what is feasibly obtainable. There was a question in chat about the ransom payments versus negotiation down. That's one of the examples as to had we had that data. So there's separate industry reports where you have anecdotal evidence, but having the two data sets mashed together, like Dr. Baker did here, where we pull TTPs together with cost, that is not something that you can easily find. That's a specific enrichment step that I was interested
in. And this is the same kind of thing. By the way, I saw a question about that supply chain compromise as an initial access technique. If I would refer you to MITRE ATT&CK there, they have 3 sub techniques, I believe, under that. Hardware additions or something along those lines, and there's kind of a range of things that are included under that technique. This is similar breakdown of you won't find post compromise in if you look at the MITRE ATT&CK tree there, but this is collapsing several of the tactics in attack after initial access through to, like, I can't remember, data exfiltration. We left off data exfiltration and impact, but all the stuff where attackers are escalating privilege and moving laterally in the organization and doing all the things that they do once they gain initial access. Here is what ransomware is trying to do. And I think this one is interesting just in the sense that you see the sort of swoops. So some of the most common techniques are less, little less impactful on the loss side. And some of the lesser common ones are more impactful, but a lot of this stuff is what they're using to find that data, to encrypt it, and then hold your for ransom. So good to know, hopefully, as you consider defenses.
and that's valuable cross-section for CISA, because a lot of advisory mitigation recommendations that we'll put out, strength is having it being evidence-based. This puts us one step closer to root cause analysis, which is currently great unification theory in cybersecurity, but moving in that direction. And this is more data that we had and more conclusions that we can draw than same analysis, let's say 5 years ago. So this is the movement in the right direction, and a really useful result for us and for the community at large as well.
Indeed, indeed. And I see a question about controls. I think that's worth mentioning, that there is research by MITRE and others to associate those attack techniques to recommended mitigations. So I think attack mitigations is one of those that you might want to check out. The question was phrased around control efficiencies, though, and I think that's one of the outstanding things I would love to figure out how to measure is, the actual effectiveness of controls against ransomware. Do we see a drop in probability of incidents from implementing a given control, or a drop in expected losses? Unfortunately, we don't have the data for that yet, but I keep hoping one day maybe that we'll get to do something like that. So
that's part of the scope that I'm pursuing as part of another initiative. The holy grail here is to combine the data that cyber insurers seen in the claims, right, to get at the losses, and then with the incident tracker data that digital forensics incident responders see and track. Well, both are client privilege information, so you have to be careful whom you ask for, what you ask, and how that could be shared, and with whom it could be shared. So they're really there are guardrails in place for a reason. And then another aspect of it is, if whoever's bringing this up as a question, if you have something that I don't, we would like to have a discussion. So there are industry publications moving in that direction. Marsh McLennan with Microsoft, where the controls that we have most of the information now to get into the effectiveness realm, or try to attempt to measure. And of course, it's p-hacking, but nevertheless is on the prevention side. What we do not have solid data to inform, parameterize, and support the analysis is on the severity side. And on the severity side, we don't necessarily even have factor models, strong factor models to have a robust qualitative discussion as to what causes what. So the question of what causes cyber risk, what causes the incidents, is still largely under-researched. But this is a step in the right direction with the sparse data that we have. Otherwise, if we don't attempt it with the data that we have, we'll be having the same conversations for the next 5-10 years to come. So thank you for advancing it in the realm of what's useful for everyone.
Maybe one day. All right, we're winding down here, so just want you to know that you can get this report. There's a lot of additional information in it. Also, I think we mentioned it earlier, but there is another IRIS coming out, IRIS 2024, probably be IRIS 2025. That CISA is sponsoring, where we're not just looking at ransomware, but we'll be taking a larger scale look at all kinds of incidents and doing some trending and other things that we haven't done in prior irises in that. So check that out. Sign up. We'll let you know when that's on the horizon. You will have access to a replay of this, and we'll make sure that you have all links. If there are any questions, I mean, happy to answer them. Looks like we've been trying to keep up with them as they've rolled through comments as we go through. But
I'd like summary of the summary as to why this is of interest to CISA and why CISA cares, because there are multiple aspects within our mission space that this report helps us clarify or reinforce the messaging. So, for example, we observe from the TTPs and then delivery TTPs as to what kind of behavioral aspects or software weaknesses lead to large losses. We talked about exploitation of public-facing applications, about 21% of the cases, and typically higher losses. We also talked about oldie but goodie, what makes DFIRS going, really? RDP, remote desktop, right? So external remote services, 18% of the time in this data set. But again, validating and verifying this with those that have the preview of the incidents, that's still bane of their existence. Some things that shouldn't exist by now because we've been so vocal as to what works, what doesn't. It works really poorly, so you need to take care of it. And then the natural question is, looking at the losses, looking at the frequencies, looking at the TTPs, what specific actions should organizations take to prevent or to mitigate, right? So we're not only preventing, we're recognizing that that's the game that's been lost a long time ago, and the discussion is that of resilience, right? We want to preclude things from happening, and then if they do happen, bounce back fast and minimize the consequences. So what it is that could be done, well, there's a lot of information that's available on stopransomware.gov for a more complete answer. There are resources there that discuss how you can, what are the controls that might help you, or practices that might help you prevent ransomware, but also prepare you for the potential worst cases so you can bounce back. So the mitigations, the response, the reporting guidance. There are also information about actors, sector-specific guidance, relevant alerts. So please do explore that resource and see what might be the most relevant to you. And then this is all the discussion of what the potential victims should be doing, right? The burden of securing their systems. And it would be remiss if we don't address the other side of the equation, is what part of this is caused by defects, vulnerabilities in the software. So there's a responsibility, equally responsibility, that should be shared by the vendor community to help us support the cybersecurity of the U.S. businesses, of the U.S. agencies. So some of the most widespread attacks did take the advantage of the widespread software weaknesses, software packages. So more complete response does require action from the vendors. And this is another initiative that we have at CISA, and it's CISA Secure by Design. It's one of the efforts in this realm. So we're seeking to rebalance what burden and investment should be shouldered by those that are trying to protect their systems versus what risks they're absorbing unbeknownst to them by relying on certain types of software products from certain vendors. And this is in no way a name and shame campaign. It's please help us collaborate. It's another example of private-public sector partnerships where we really need vendors to step up to help secure this ecosystem. So any data analysis would be greatly appreciated. Anything where we can see proactive steps, that's something where amplify the messaging. So please check out the CISA Secure by Design initiative as well. The goal here is inform risk management decisions, make this information available to the public, make this information available to the vendor community, and also be in touch and be respectful of multiple equities involved, and hear the feedback as to where we should take this analysis next. And potentially there are some things that we're overlooking and there are objective gaps that could be addressed if we have good input from our audience. So thank you for your time and letting us walk you through this very important analysis. And Wade, thank you so much for the partnership. Looking forward to another round.
Yeah, me too. Thank you. All right, everybody. We appreciate you spending some time with us, and always open to feedback after we shut this down. If you have other ideas